Okay, this is exercise 3.10, and this is a nice problem too. Even though I think the idea is goofy, I give the students credit for fooling around with it, but I don't know. Well, it's a good way to learn in any event. And what you had to do is create a scatter plot of the data, evaluate the linearity within the given range of activity, then run a regression model so that we know what we're going to conclude from the scatter plot. So then we can run a regression model and see what the statistics tell us and take a look at what the formula is. And then evaluate the validity of the best fitting line in terms of goodness of fit, significance of slope, and economic plausibility. Okay, so that should be starting to sink in, right? So what wait a minute, where's my scatter plot? 310. Oh, let's just look at it really quick. It comes up with it. Well, it didn't. Oh, I have one here. There it is. That's what the scatter plot looks like. And it's food expense based on the number of days in the house. Okay. And the thing of it is, where would you begin? Where would you start your line? Maybe right down the middle like this. I'm not sure we could even agree maybe on where to put it. Well, some places would be better than others, but it doesn't look very linear, does it? They don't clearly follow a linear pattern within this range of activity. I wouldn't put money on a cost function that came out of this. Okay. So then the next thing we did was we ran a regression, and this is the output from the regression. And it's nice because here's our regular formula. So this would be 3.14 times the number of nights. I'll just do this. Plus our fixed cost our intercept is 259. Okay, that would be what the total cost would look like. 3.14 times the number plus 259. Does the 259 make sense if we look at this? Yeah, probably. There's 200, so they're saying 200 to 300, so 259 might be a little bit higher, right about there. That's what for the fixed cost, that's what the formula tells us. Okay, so let's see what else we can get out of the output. Probably the most important thing is the R-squared. And the R-squared tells us that this graph explains nothing, okay? That it only has, it only explains 7% of the variance. One of the other things that we haven't talked about here that's really important though too is that our numbers are low. We've only got 9 observations, and you need more observations than that to draw any conclusions. Okay? Then if we look at the significance, the p-value of the slope, okay, which would be the number of nights, it's also not good, 0.46. And we're looking for something that's 0.05 or less. Okay, and this t-statistic is negligible. This would have to be higher. Okay, but what you can pay attention to, though, is just the p-value. So the regression doesn't support the relationship either. Okay, what else do we have here? Okay, so here's our evaluating the goodness of fit. Here's our cost function. Y equals 3.15x plus 259.5, and we get that right off. These are the coefficients, and they're the labels for them, okay? And your intercept is always your fixed cost, and the nights there would be variable cost. R-squared is very low, so the line is not a good foot for the data. A good, what should that word be? Line is not a good feel. What did I mean here? What should this be? A good, I'm going to say formula. Foot. In any event, it's not good. Significance of the slope, the p-value is high, 0.46, and that value should be less than 0.05. Economic plausibility, not a convincing relationship. Maybe it's part of it. And one of the things that we have a TA that comes to the night section, and one thing, he's a PhD student, and one of the things he said is, of the months that we're including in here, December, we've got a holiday, people are gone pretty early, but they still have 25 days. In May, they actually have 36 nights, but in May, people leave too. So, I don't know. I think it's just the relationship itself that doesn't make any sense. Okay, all right, I think that's everything that you need for this.